Charles Darwin, in the later years of his life, came to write several letters to some of his closest friends in botany on what he called the abominable mystery. How did flowers erupt all across the world almost instantaneously in the fossil record? Pollen, nectar, fruit, floral scents and colors, all these traits all at once. Natura non facit saltus, he cried. Nature does not make a leap. Hello, and welcome to the first part of Flowers of the World on the earliest diverging living flower, Amborella trichopoda. Its tiny, fuzzy white flowers grow in the tropical forests of New Caledonia, where the climate has remained stable for several million years. Is this, perhaps, what the earliest flowers look like? Is this Darwin's answer, his missing link at the base of flowering plant lineage? Amborella trichopoda represents the sister taxon to all other flowering plants, and so perhaps it is natural that it gets its own entire order, Amborellales, all to itself. For context, the largest order, Asterales, contains over 20,000 species. Its unique position was determined relatively recently, too, with evidence from multiple independent DNA analyses conducted in 1999. And it was finally recognized by the APG as the most basal extant angiosperm in the APG3, published in 2009. Before that, it was placed a bit further down in the tree of life, typically with the magnoliids. Imagine that, if you were born after 2009, you are younger than this brave new era in which most botanists finally agree on the true base of extant angiosperm phylogeny. If I was making this video before then, I'd be starting with the Austrobaleales instead. Before we dig into the mystery proper, I'd like to give a brief description of Amborella flowers to have as a starting point. Amborella is this woody, understory shrub endemic to New Caledonia that could grow up to 6 or 8 meters tall. It is dioecious, meaning each plant either produces the male staminate flowers that produce pollen or female carpellate flowers that form fruits upon pollination, but never both at once. In cultivation, however, cuttings from one plant have been observed to change sex and produce the other flower after a second flowering. In rare occasions, some male plants have even been observed to produce bisexual staminate flowers with ovaries in the center. Each flower has anywhere from 6 to 15 small curled tepals, tepal being the term used to refer to the outer parts of the flower in the perianth that can't quite be categorized as either a petal or a sepal. The staminate flowers are characterized by many triangular pollen-bearing anthers, 10 to 21 per flower, giving them a distinctive fuzzy appearance. The carpellate flowers are a bit less impressive, with 4 to 8 green ovaries that form red drupes on pollination, 1 to 3 per flower. The fruit is mostly taken up by a pit, with a papery thin skin and a green fleshy layer. I unfortunately have no sources that tell me how it tastes, but most studies do cite a complete lack of aromatic oil-producing cells in the plant, rather uncommon for flowering plants, so the flowers and fruits should have no fragrance. Speaking of common, apparently primitive traits, Amborella contains quite a few that distinguish it from the rest of all flowering plants. Could we perhaps infer that early flowers shared such traits? Turns out answering such questions can be difficult. To list a few of these traits, Amborella lacks floral scents and colors present in most other flowers. Amborella flowers are highly reduced, with a very small perianth of undifferentiated tepals instead of petals. Amborella is dioecious. Only about 6% of flower species are entirely dioecious. And finally, Amborella lacks vessel elements in its wood. Some of these traits aren't too difficult to answer for once we correlate features with the fossil record. For example, Amborella entirely lacks the genes for scents and colors, evidence it is a primitive trait shared by the first flowers and evolved by a common ancestor that diverged after Amborella diverged. Some fossil evidence does seem to suggest that the first flower was similar in structure to Amborella, small with undifferentiated sepals, but specific questions about morphology remain difficult to answer even today. For example, recent research makes it quite certain that the first flowers were likely bisexual and not dioecious as in Amborella. As for vessel elements, well, nowadays the evidence is more clear on the matter, but the question enjoyed some fierce debate before the modern taxonomy was established in recent decades, and I want to dive into it for the bulk of the video, not just because it shows the process of cladistics as it evolved over the past century or so, but also because of how questions like these help sort out the early evolution of flowering plants and show how we've begun to take apart the abominable mystery. First, what are vessel elements? Well, vascular plants use cells called tracheids to transport water and dissolved minerals up from their roots to their leaves in what is called their xylem tissue. Tracheids are these elongated cells with many pits in them that connect to other tracheids. As water evaporates from the leaves, the negative pressure pulls water up through the xylem, where it zigzags from one tracheid to the next through these pits. This system naturally incurs quite a bit of resistance, and the hydraulic capacity of connected tracheids is less than, say, a continuous tube or a straw. The benefit, of course, is that if one tracheid is damaged, water can still move through neighboring tracheids, whereas a continuous tube or hose that is pinched or clogged at any point will cause failure of the entire structure. Regardless of the danger, however, a continuous vessel does indeed offer great advantages in water transport, which would have significant advantages in drier climates. So, perhaps it is no surprise then that early angiosperms would end up differentiating some of their tracheids into vessel elements, cells which are similar to tracheids, but with larger holes at the top and bottom called perforations that connect into one another, creating continuous vessels for increased flow. Vessels are a characteristic feature of angiosperm xylem that is thought to have been yet another key innovation, alongside flowers themselves, that catapulted the diversification of flowering plants across the world. Vesseled wood marks the difference, for example, between the hardwood of flowering trees and the softwood of conifers. So, Amborella lacks vessels in its wood, a rare soft-wooded angiosperm. Does this mean it diverged before most other angiosperms gained vessel elements? This was the opinion of many botanists in the early 20th century, most famously the American horticulturalist Liberty Hyde Bailey, who suggested flowers were primitively vesselless, as in, the most recent common ancestor of all flowers lacked vessels, but once an ancestor developed vessels, they were so useful that reversals to vessellessness was rare if not impossible. Therefore, extant vesselless plants must have diverged before the ancestor that evolved vessels. This viewpoint was first challenged in a 1981 paper by Professor David A. Young, where he looked closely at several flowers that were considered to be primitively vesselless to determine whether it was more likely that the most recent common ancestor was vesselless or that it was in fact vesseled, and extant vessellessness in these species is actually a derived feature. At the time of his publication, the APG did not exist, nor did reliable DNA sequencing, so Young constructed this cladogram here from examining over 40 character traits of each flower to map out this tree, which his argument relies on. Note, the extant vesselless families thought to be primitively vesselless are capitalized here in Young's diagram. Assuming a vesselless ancestor at the base of this tree, Young marked the points at which vessels would have to independently arise in order for the vesselless families to be primitively vesselless, a total of 10 times. In contrast, if we assume a vesseled ancestor, only 3 or perhaps 4 reversals would be implied by this cladogram. This spurred several other botanists, like Donahue and Doyle in 1989, and LeConte and Stevenson in 1991, to reach similar conclusions in their own taxonomic systems. It seemed to them that assuming a vesseled ancestor was simply making less assumptions than assuming a vesselless one. Could this perhaps be true? Did nature in fact make a leap, developing two radical innovations, flowers and vessels, in a single step? Well, Pieter, Baas, and Elisabeth Wheeler reviewed the evidence in 1996 and argued that the parallel development of vessels might be more likely than reversals of the same kind. After all, a group of gymnosperms, the Nitales, independently evolved vessels, in addition to some species of fern. Still, they could not make a call either way, and thought more accurate cladograms could shed light on the issue. So, what about now? What can we say today with the advanced taxonomic systems developed by the APG? Well, the answer unfolds quite a bit more easily, as it turns out. Here's Young's cladogram reorganized under the APG-4. Can you mark where the likely emergence and reversals of vessels might have occurred? If you drew one gain before the Austrobaleales and three reversals before Sarcandra, Winteraceae, and Trochodendraceae, you'd have reached the same conclusion as most botanists did after the APG-3. I'll admit, it's almost anticlimactic that such a difficult problem had such a simple answer. The earliest flowering plants were, indeed, vesselless, a feature preserved by Amborella and the Nymphaeales before developing vessels shortly before the vast diversification of most other flowering plants, and experiencing occasional reversals in some small groups. I hope you look forward to when I talk about those plants, by the way, as the reasons why we think they each lost their vessels is different and interesting in almost every case. To conclude this section, there is probably a similar story behind the various other features that were developed in the rapid evolution of flowers during the Cretaceous that we still do not fully understand. But I would argue that Darwin's abominable mystery unravels as we speak. Each year, new publications reveal exactly the series of steps that comprise the leap nature took with flowers. Digging into the primitive and derived characters of Amborella reveals how our knowledge of this subject has evolved in the past century and a half since Darwin. I'm sure he'd be proud. For the second half of this video, I'd like to talk about the history and culture that is related to Amborella. And before I touch on the specific history of the plant, I think it is impossible not to acknowledge the recent history of New Caledonia, to which Amborella is endemic, especially due to the recent unrest on the island territory beginning in May 2024. New Caledonia, or Nouvelle-Calédonie in French, is an overseas sui generis collectivity of France in Melanesia, which means the New Caledonian citizens are French citizens also. I'll be honest, I had no idea France still had a territory essentially on the opposite side of the world before researching this video. To be fair to myself, such territories tend to be rare in the modern era, as many other similar former Pacific Island colonies gained independence in the 60s and 70s, like Fiji, Western Samoa, and Papua New Guinea, to name a few. In New Caledonia, a similar independence movement that led to the independence of these other colonies started in the 70s, headed by the indigenous Kanak people of the island. Up until 1946, the Kanaks did not have freedom of movement nor freedom from compulsory labor, and citizenship regardless of ethnicity was not granted until 1953, only 60 years ago. Naturally, this leaves its mark in the severe economic disparity between Kanaks and Europeans that remains starkly visible today. This disparity led to tensions rising between Kanak and European communities, erupting in a period of violence in the 80s termed simply the Events, in which French military deployed to the island in large numbers to suppress the unrest. Peace accords were finally signed in 1988 and then in 1998, which guaranteed a 20-year transition period that would end with up to 3 referendums on independence to be held no earlier than 2018.
Fast forward 20 years to 2018, when referendums can finally begin. The first, in 2018, saw 56.7% voting to remain. The margin grew slimmer in the next referendum in 2020, with only 53.4% choosing to remain. The final referendum was scheduled in 2021, but in the wake of deaths from the COVID-19 pandemic and the long traditional mourning period of Canucks, pro-independence leaders asked French authorities to delay the referendum. This request was denied, which led to the boycott of the referendum, resulting in an overwhelming vote to remain and leaving no clear path to independence. The recent unrest in 2024 arose out of initially peaceful protests against a motion in the French National Assembly to expand the voting list to include the residents that moved to New Caledonia after 1998, when the peace accords were signed, representing a sizable amount of the population in the past 20 years. The motion passed, sparking tensions all over again, heightened especially that year by a collapse in the nickel sector that employs a quarter of the population. The violence caused widespread destruction, especially of large commercial establishments owned by wealthy European families that were seen as having profited from colonialism. A state of emergency was declared, the French military was again deployed to the island, leading to 13 deaths, mostly Kanak. Violence has cooled as of writing in early 2025. The most recent news out of New Caledonia has seen the government of pro-independence President Louis Mappo fall and be replaced by one led by non-independence President Alcide Ponga, likely marking the end to the possibility of an independent New Caledonia in the near future. I understand all this history might seem like an unrelated rabbit hole to include in this flower video, but I think it's important to keep in mind the timeline as I discuss the early publication history of Amborella, which occurred in the wake of France's annexation of New Caledonia in 1853. Our early knowledge of this plant is a product of colonialism, and I think it's worth at the very least acknowledging that history. Now, let's move on to publication history. The species was first published in 1869 by French botanist Henri-Ernest Bayon in the first edition of his Histoire des Plantes. The species name, trichopoda, means hairy foot in Latin, which I believe comes from the many fuzzy anthers that characterize the staminate flowers, which were the only flowers known of in early publications. And I say I believe because that's the best I can do, really. See, I read the first edition of Histoire des Plantes, where Amborella trichopoda was first named, in a small footnote where Bayon called it a provisional name and didn't give much more context. So I looked up the more complete treatment Bayon gave in the 10th volume of his journal Ad Ansonia, published in 1873, where he also did not mention where the name came from. He did, however, mention that the specimens he studied were collected by botanists Eugène Villard and Benjamin Balança, who were known to label their collections by species name and not by date. So I tried to dig into their publications, and that's where the trail ran cold. For me, at least.
So all I can do is speculate on where Amborella comes from, unfortunately. Here's my best guess, assuming a Latin root. Amb could be from ambi, for both or around, or would mean mouth in Latin, and ella might be a diminutive suffix. So, around a small mouth? Anyways, moving on.
Bayon's initial treatment placed Amborella within the Monimiaceae, a family containing similar small trees and shrubs that inhabit tropical ecosystems, in particular emphasizing how the Amborella flower resembled small Hedycaria flowers, and believed they must be closely related. His categorization led to a few other authors to include it in their writings on the Monimiaceae, such as American-born botanist Janet Russell Perkins, who gave the earliest illustrations of Amborella material in her 4th edition of Betrages zur Kenntnis der Monimiaceae, published during her time studying in Germany. Monomiaceae is placed within the magnoliids, which is still amongst the most basal of angiosperms, so I might be covering it sooner than later. But with over 200 species, Amborella was just one basal flower among many. As a consequence, Amborella garnered little attention in academia for decades until 1948, when a few original samples collected by Villard and Balança happened to find themselves in Harvard University's herbarium, where botanists Irving Whitmer Bailey and B.G.L. Swamy noticed the absence of vessels in its wood and published their findings that year. It was a surprising find for the time, as most other vesselless flowers had already been published on in the 19th century, and it stirred up a few papers on the subject, perhaps most importantly the 1981 paper by David A. Young I mentioned earlier on when discussing this particular characteristic of Amborella. But Amborella did not truly take on the limelight until the DNA analyses of 1999 cemented its place at the base of flowering plant phylogeny. In this graph from a 2019 paper by Poncet et al., you can see how the number of publications on Amborella erupts after 1999. Its title as the most ancient flower, however imprecise, motivated the complete sequencing of its genome in 2013 and increased preservation efforts, which benefit many other relic species endemic to New Caledonian forests. Even today, new discoveries keep emerging that continue to expand our knowledge of the evolution of early flowers. For example, an examination of the genome revealed that Amborella has experienced a surprisingly large amount of horizontal gene transfer from lichens and algae that grow on and around it in the forest understory. Did this happen before or after diverging from other flowers? What could this imply about the amount of horizontal gene transfer in other plants? And how could that affect our current understanding of plant phylogeny? I, for one, am excited to see what the next abominable mystery will be. Thanks for watching me draw the first flower in my series. As I mentioned in the introduction, I'm not a botanist or historian, so if I did get anything wrong, please let me know down below. And if you liked watching this one, please consider subscribing so you won't miss me next time when I'll be covering Hydatellinaceae, the first of the Nymphaeales.